Hello everyone, and welcome back to the video lecture series on radical expressions. Today we are going to be working with what are called nth roots and rational exponents. So rational exponents are exponents that are fractions. And even when your exponent is a fraction, the same exponent rules that you learned way back in chapter 4 are going to all still apply. Now, rational exponents are closely tied to radicals. So what you're going to do is I want you guys on your own to evaluate each of these on your scientific calculator. Now, in most scientific calculators, you do need to put parentheses around the exponent, so you will type this in as 4 to the power of parentheses 1/2. And I want you guys to take a second, pause the video, and evaluate each of these. So once you are done evaluating these, 4 to the power of 1/2 is 2, 9 to the power of 1/2 is 3, 16 to the power of 1/2 is 4, and 25 to the power of 1/2 is 5. And you might notice that raising these numbers to the power of 1/2 was the same as taking their square roots. So 25 raised to the power of 1/2 is the same as taking the square root of 25, which gives you 5. Same thing here, 16 to the power of 1/2 was the same as taking the square root of 16, which gave you 4. So these rational exponents are actually radicals in disguise. So you can write this expression in two forms. When you actually have the root symbol, this is what is called radical form. So square root of x is called radical form. When you rewrite that square root as an exponent of 1/2, this is what is called exponential form. And since these two forms are exactly the same, you can freely move back and forth between these and convert back and forth between these. Now, square roots are not the only type of root that exists. We have what are called nth roots. So if you have an nth root of a, it'll equal b, meaning that the a equals b to the nth power. So basically, this nth root is what is called a radical, and this little n here will actually be a number, and it is a tiny little number that is nestled inside of that root symbol. That number, which is going to be a whole number, an integer, is what is called the index. That gives you what type of root you have. And remember, then whatever is inside of this root is called the radicand. Now, when your index is 2, you have a square root. So square roots are one of those roots that are so common that the index is just not written. It's just like we don't write the power of 1 usually, and we don't write the 1 in front of a variable usually. This is another one of those. So if your index is 2, you actually have a square root. So if you have a radical with no index, its index is 2 and you have a square root. Now, if your index is 3, you have what is called a cube root, and it is written like this. So this is read as the cube root of a. This little tiny 3 is not being multiplied. That little tiny 3 is the index, and that just tells you what type of root you have. You have a cube root. We're going to talk more about those in a second. Now, there are other indexes. Your index can be any whole number. So this is what is called a fourth root, meaning your index is 4. You can have fifth roots, you can have sixth roots, and so on. Now, talking a little bit about cube roots are the opposite of cubing. And remember, cubing is multiplying it by itself 3 times. So when you're looking at the cube root of 8, what you are asking yourself is, what number cubed gives me 8? Or what number times itself 3 times gives me 8? Well, 2 times itself 3 times gives me 8, so the cube root of 8 is equal to 2. That little tiny 3 is called the index, and it basically told you what type of root you have. Now, in exponential form, the cube root of x can be written as x to the power of 1/3. So we're going to evaluate each of these without a calculator, and these are examples of what are called perfect cube roots. So for the cube root of 27, what we are asking ourselves is, what number times itself 3 times gives us 27? Well, 3 times itself 3 times gives us 27, so the cube root of 27 is equal to 3. Then for the cube root of 64, what you are asking yourself is what number times itself 3 times gives me 64, which is 4. And then for this last one, for the cube root of negative 8, what you are asking yourself is what number times itself 3 times gives me negative 8. Remember, when you take an odd number of negatives and you multiply them, a multiplication of an odd number of negatives is negative. So what number times itself 3 times is negative 8? It's actually negative 2. So you can take the cube root of a negative number. It is simply negative. So in general, if you have the nth root of a to the n, anytime that your power matches your index, they are going to cancel each other out. That is why the square roots and squared always canceled each other out, because the index was the same as your power. So cube roots and cubes are also going to cancel each other out because the index matches your power. And if it's an odd root, it's just a simple, cross them off and they cancel each other out. If your index is even, it's just the absolute value of a. Now, there are other types of roots. When your index is 4, we have what is called a fourth root. A fourth root is an opposite of a power 4. So for the fourth root of 16, what you're asking is what number times itself 4 times gives me 16. Well, 2 times itself 4 times gives me 16, so the fourth root of 16 is equal to 2. Now, what about the fourth root of negative 16? You would be asking yourself, what number times itself 4 times gives me negative 16? Well, even if you take negative 2 and multiply it by itself 4 times, you will still get positive 16. So there is no number that times itself an even number of times gives you a negative number. So this is undefined. So you basically cannot take the even root of a negative number. However, the odd root of a negative number is negative. And then in exponential form, the fourth root of x can be rewritten as x to the power of 1/4. Now, fifth roots are the opposite of a power 5. So when your index is 5, you have a fifth root. So for the fifth root of 32, what you are asking yourself is what number times itself 5 times gives me 32. Well, 2 times itself 5 times gives me 32. So the fifth root of 32 is equal to 2. Now, for the fifth root of negative 32, what you would be asking yourself is what number times itself 5 times gives me a negative 32. An odd number of negatives is negative. So the fifth root of negative 32 is actually negative 2. So the odd root of a negative number is negative. The even root of a negative number is undefined. And then in exponential form, the fifth root of x is equal to x to the power of 1/5 written as an exponent. So what we're going to do for each of these is we are going to take all of these rational exponents and we're going to write them as radicals. If you've noticed, the denominator of your exponent is the index of your radical. So for x to the power of 1/3, the denominator is your index, so this is the cube root of x. For x to the power of 1/2, the denominator is your index, so this is the square root of x. We don't write the index of 2. Then for x to the power of 1/9, the denominator becomes your index. So this is actually the 9th root of x. Now for each of these, because the numerator was equal to 1 for each of these were all x to the power 1s inside of your radicals. Whenever your numerator is any number other than 1, your power is going to be whatever the numerator is. So the denominator is your index and the numerator is your power. So for x to the power of 3/2, the denominator indicates our index. So since the index is 2, we have a square root. And the numerator is the exponent on our x. So this can be rewritten as the square root of x cubed. So then for the next one, for x to the power of 8/5, the denominator is your index. So we have a 5th root. The numerator is your power on x. So we have the 5th root of x to the 8th. And then for this last one, the denominator is your index. So we have a 7th root. The numerator is your power on x. So we have the 7th root of x to the 3rd. Now for each of these are currently in radical form, and we are going to write them in exponential form. So the power that the variable is raised to is the numerator. The index is going to be the denominator. And remember, it doesn't matter what order the powers are in. So for this first one, the index is 4. So the denominator of my exponent is going to be 4. The power that we raise it to is going to be the numerator. So this can be rewritten as x to the power of 5/4. So then for the next one, remember, if you do not see an index, your index is 2. So the denominator is going to be 2. The numerator is the power that we raised it to, so the numerator is 5. Then for this next one, the index is going to become your denominator, so your denominator will be 4. The power that we raise the variable to is going to be the numerator. Now 8/4 can simplify as x squared. Then for this next one, the denominator is going to be your index, so your denominator is going to be 3. The numerator is the power that we raise it to, so the cube root of x squared can be rewritten as x to the power of 2/3. So then for this next one, it doesn't matter whether the exponent is inside the square root or outside the square root. Remember, they are interchangeable. So the index is going to be my denominator, so my denominator is going to be 8. The power that it's raised to is going to be the numerator. So this can be rewritten as y to the power of 3/8. And then for this last one, the index is going to be your denominator, so your denominator is 7. The power on your variable is your numerator, so the 7th root of x to the 6th can be rewritten as x to the power of 6/7. Now what that also means is if you remember that rational exponents are just square roots, you can evaluate each of these, if possible, without using a calculator. So 16 to the power of 1/2 is the same as the square root of 16. Square root of 16 is 4. For 27 to the power of 1/3, remember, you can rewrite that power of 1/3, as the cube root of 27. So what number times itself 3 times gives me 27? The answer is 3. Now for this next one, for negative 81 to the power of 1/4, remember, your denominator is your index. So this is the 4th root of negative 81, really to the power of 1. You cannot take the even root of a negative. So this is undefined. There are no numbers that multiplied by themselves 4 times gives you a negative 81. Now for this next one, for 32 to the power of 1/5, the denominator is your index, so we have the 5th root of 32 to the power of 1. So what number times itself 5 times gives us 32? The answer is 2. Then for this next one, an exponent of 1/3 is a cube root, so we're taking the cube root of negative 64. So we're going to ask ourselves, what number times itself 3 times gives us negative 64? You can take the odd root of a negative number. The odd root of a negative number is negative, so the cube root of negative 64 is just negative 4. And then for this last one, the denominator is your index, so this will become the 4th root of 16 to the power 1. For the 4th root of 16, what you are asking yourself is what number times itself 4 times gives us 16, which is 2. So then for this next one, for negative 4 raised to the power of 1/2, an exponent of 1/2 is the same as a square root. You cannot actually take the square root of negative 4. There is no number that times itself gives you a negative number. So this is undefined. You're going to work more with expressions like this later in college algebra, but for now in this course we're just going to call it undefined. Now for these next two, whenever you have a negative in your exponent, you might remember from way back in chapter 4, there is a way to simplify this to make it a positive exponent. So since there is no denominator, I am going to create one. I am going to take the base and that negative exponent, and I am going to put all of them into that denominator to become 64 to the power of positive 1/3. And then you might remember that if you don't leave anything behind, there is a 1 in the numerator. So then, an exponent of 1/3 is the same as a cube root, so this is the same thing as 1 over the cube root of 64. For the cube root of 64, you were asking what number times itself 3 times gives me 64, which is 4. So your final answer is 1 over 4. So then for this last one, we're going to do the same thing. If there is no denominator, we're going to create one because that negative exponent is going to move into that denominator to become 4 to the power of positive 1/2. If you don't leave anything behind, there is a 1 in the numerator. So 4 to the power of 1/2, 1/2 written as a radical is a square root. So square root of 4 is 2, so your final answer is 1/2. And then for each of these, we can evaluate each of these without the use of a calculator. We're going to do that by taking these and rewriting them in radical form. So for 4 to the power of 3 over 2, the index is the type of root you have. And since the index is 2, we have a square root. The numerator is what we are raising it to, and I'm going to raise it to the 3rd power. And again, it doesn't really matter whether the power is inside the root or outside. I will say that taking the square root first and then raising it to the outside power is easier because taking the square root will make the number smaller before you have to worry about multiplying it by itself. So this is just my recommendation. So we're going to do the square root first. The square root of 4 is 2. 2 to the 3rd power, 2 times itself 3 times is 8. So for number 2, we're going to do the same thing. We're going to rewrite this in radical form first. So the denominator becomes your index, so we have a 4th root. So we're going to take the 4th root of 81. The power we raise it to is the numerator, so we're then going to raise it to the 3rd power. So for the 4th root of 81, what you are asking yourself is what number times itself 4 times gives you 81? Well, you can deduce that it is 3. 3 times itself 4 times will give you 81. Then we're going to take that 3 and raise it to the 3rd power. So 3 times 3 times 3 gives us 27. And then for this next one, if there is a negative that is not in an exponent, you don't need to worry. The negative here is not in the exponent, so we don't have to worry about any fractions or anything. But if the negative is in parentheses to start, it does need to stay in parentheses throughout. So I'm going to leave the negative 32 in parentheses. The denominator is the index on your radical. So we have a fifth root of negative 32. Then the power that we raise it to is the numerator, so then we're going to square it. So for the fifth root of negative 32, you can take the fifth root of a negative number. What number times itself 5 times gives you negative 32? So negative 2 times itself 5 times gives me negative 32. Then I'm going to take that and square it, and notice how this is in parentheses. Negative 2 parentheses squared is 4. And then for this last one, when your exponent is negative, you do need to rewrite it as a positive exponent first before you can go evaluating. So I'm going to take all of this, I'm going to move it into a denominator to become 64 to the power of positive 2/3. And because there was nothing left over in the numerator, I put a 1 in the numerator. So then I am going to rewrite this as a radical. The index is your denominator, so we have a third root, so we have the cube root of 64. And then the numerator is the power you raise it to, so we're going to raise it to the power 2. Cube root of 64 is 4. 4 raised to the power 2 is 16, so you get 1 over 16 for your final answer. So that is it for the video lectures on radical expressions, and because this was the last video lecture for this chapter, this is actually the last video lecture for this course. So thank you all so much for watching. I really hope that these were valuable for you, and I really hope that you were able to learn a lot from them. And I did put a lot of time and work into these, so thank you all so much for watching. It really means a lot to me that you're watching these and learning from these. So thank you all so much for watching these video lectures. If you have any questions, please don't hesitate to email me, and I will see you all later. Bye-bye.